Hello, my name is Yoon Chung Han. I'm assistant professor at San Jose State University. Today, I'm going to talk about my work, Rows in U, Matching and Visualizing Veins, and Rows in 3D. Rows in U is an interactive biometric data art and physical 3D data visualization by using a vein matching process to roads. In this artwork, participants scan their veins, capture the aesthetically formed vein lines, observe existing roads in the earth that match to the veins inside of their bodies. The surprising results discovered through this process are visualized in both interactive 3D map visualization and then 3D printed sculptures as a personal souvenirs as a part of the artistic experience. Unique aspects such as artistic expression and the situated metaphors in this artwork invite audiences to experience a unique matching process and discover newly meaningful roles for them. Enhanced 3D visualization and the physical data sculptures are the new additions to this updated version. This data-driven artwork aims to find an interesting correlation between biometric data and the map-based data in terms of research questions. Human vein is one of the biometric data that has been commonly used for various identification devices due to its unique patterns and contactless input data. Veins are beautifully complicated forms hidden under skins. It includes many intersections of the roads that resemble the streets and paths surrounding us. The geometric shape and the topological structure of the vein pattern resemble the roads and streets in the world. Unlike the constantly changeable roads by the human's impact, the lines, bifurcations, and patterns of the human vein stay the same for the entire life that can be considered as a biometric trait. What if there are roads that match your veins in the world? This was my initial question that started the whole research and investigation through this art form. So this artwork explores how the line segmentation and the structure of the veins can be compared to the existing roads in the real world. From an artist's perspective, this project can also suggest an exciting artistic platform where spectators create surprising results and the narratives. So the biometric data becomes input data for the storytelling. So in this work, similarities and differences between two different data, vein data and then roads, are explored, and which has never been attempted in previous artistic practices or scientific research, although there are cases of relevant scientific research using palm or vein lines. The previous version of this roads in U show the preliminary approaches to the matching process, computer vision, and initial result. In this paper, the updated version of the artwork was introduced, and it includes more enhancements on the matching process, 3D visualization, and the additional features on the interactive application, and more detailed information about matching roads, and 3D printed data sculptures for the participants. Rows in U consists two parts, interactive data visualization and the physical 3D data sculptures. First of all, participants can first scan their veins in the interactive application. They can capture veins in any part of their bodies by using the customized infrared camera. For the best result, veins on the wrist have been recommended since it's clear, unique, and easily achieved. And captured veins are analyzed through image processing techniques to extract unique vein lines. So various computer vision and image processing techniques were used for the line detection process. The finally pulled lines are sent to the matching process with the pre-saved map images on the computer. And matching process includes analysis and matching algorithms to detect the best matching rows in the map data. Users can choose the locations where they want to search their roads, such as cities or countries they want to explore. Otherwise, the roads data range is open to anywhere on the Earth, and the best matching roads are highlighted and visualized. On the screen shown here, users can see two colored lines on the right side. So green lines represent their vein lines, and the red lines represent the matched roads. The green lines are above the road, the red road lines, to support the understanding of the relationship between those two data. And as you can see on the left side, there's the original row, the vein line image, and then there's extracted rows data from the row map data platform on the right, the bottom side. Looped animations on the rows mimic the blood circulation in the veins and the liveness in the earth and the urban areas. Users can drag to see the map from different angles or zoom in and out to see the rows further or closer. The captured original vein image and the extracted skeletonized lines appear at the left bottom corner of the interface. The address of the selected location appears at the center of the screen. The name of the city, longitude, and latitude appear at the right bottom corner of the screen. So users can click the try again button to restart or click archive to observe other outcomes from other users. The updated version of this Rosin U, the artwork, has been installed in Seoul, South Korea as an informal user study in August 2020. About 15 participants experienced this artwork, and then results are shown in these images like this. Each participant scanned their various parts of their body and they explored the different rows matched to their vein data. The participants had playful experiences with all the other results on the screen. So these are the distinct results from the case study. So as you can see, all the veins are different, and then it matched to different regions in different cities. So the 5 distinctive results show all different locations in cities such as rows in Amsterdam, Sydney, Tokyo, and Seoul. Overall, it was hard to find the perfect matching rows in the world because, but the big rows were matched with the thick vein lines, more than 90% accuracy. And short and disconnected vein lines show the lower accuracy on the matching results. However, overall, the participants were able to understand the relationship between the two data and satisfied with the matching results. Participants expressed a high interest and the active engagements on exploring the matched roads and the 3D printed works. They were excited to see many different results of the matched locations and the highlighted roads on the screen. So as you can see here, the installation consists of several parts. A live and interactive application is the main component of this artwork, where users can scan their vein data with a customized infrared camera. 3D print sculptures in the customized picture frames are installed next to the interactive installation. An extra display is next to the sculptures to show the archive website for other participants. The personalized experience is one of the significant aspects of this artwork. As a participant input their vein data as art materials for this installation, they acquire the final outcome as a part of the experience and then keep them as a personalized souvenirs. So 3D printed sculptures are good ways to document the final results. Furthermore, it shows the matched result with the detailed information about the location and the road data. So in the pre-installation, 3D printed sculptures were arranged on the top of the map print to show the road data and the vein data simultaneously, as shown in these images. So, and then there were 2 color choices, red and black. So in the future exhibitions, participants can request printing their vein data and matching roads in different colors as well. And selected unique data will be also printed and then to show the various results from this artwork. So in conclusion, this artwork, the vein data becomes a fascinating art form that reveals beautifully integrated roads and paths underneath the skin that are invisible to the naked eye. The roads and paths are recreated and they're added on top of the cities, regions, and the areas surrounded us. This work aims to propose a new way of visualizing the correlation between the individuals and environments using vein recognition techniques and image processing. This project also has a potential to lead the way in the interpretation of complicated data sets while providing aesthetically beautiful and mesmerizing visualizations. The human body's connection to the real world can lead to the new opportunities to explore their own geological signature. Furthermore, this work could address environmental issues and question the difference between naturally generated data in human bodies and artificially created data in our world. This work also requires a contact list interaction, as veins can be detected with the infrared camera in a relatively short distance. Therefore, it can be possible to suggest a new contact list and a safe input system for personalized artworks, but still keep good user engagement using their body data as art materials. Through the contact list interaction, it is more convenient and hygiene, which leads to high safety and user satisfaction about the interactive experiences. Future works include more enhanced quality on matching result. When users select a certain cities or regions where there are not enough number of rows or lower complexity in the road, final match results were not satisfied. So updated version of this application could include the options to show alternative locations where contain better matching roads. Furthermore, expanding to various road types or other geological data such as rivers or trails, contours will increase the range of the road detections. 3D printed sculptures could have more personalized aspects such as different color choices, textures, and embedded maps as a part of their sculptures. Exploring other parts of the human body data and the data sonification changing to the sound are next steps for this research project. Thank you so much for listening to my presentation. I can take any questions you might have. Thank you.